deep learning. So without knowing the concept of back propagation algorithm, we will not be able to design any network. So in the first unit itself, we have seen different models of neural networks where feed forward network, that is a basic model, but basic model is just a base only. It has lot of disadvantages too. For simple problem alone could be solved by the basic model. We require back propagation properly into the feed forward network. That is how this back propagation algorithm got into existence. Okay, so please remember, back propagation is a backbone of deep learning and neural networks. Without the concept of back propagation, we will not be able to design any neural networks. That's the reason we give so much importance towards that. This whole unit is about that. How we are implementing back propagation, what are all the mathematical concepts involved into that. With the architecture, I just gave you the explanation. How far you have understood, I don't know. So we will take a very simple network, and with that, what are all the concepts involved. So here we will be seeing about gradient learning or gradient descent. That is to optimize the network. So what exactly back propagation does? Back propagation, it goes backward. Okay, so you just give the input will be processed through various hidden layers. Finally it will be sent to the output layer. That is the normal flow of any feed forward network. Fine. When there is any error, I give you a very simple example, what we see in our day-to-day life. Okay, fine. So your parents are giving time. Imagine that you were in school. Okay, so you can play for 2 hours. Your playing time is 2 hours. Study time is 4 hours, and sleeping time is 8 hours. So this is how they just gave you when you were in 9th standard. Okay, so finally we see your result when you complete your 9th standard. If you have secured very good marks, if you have secured very good marks, there is no loss in this system. There is no loss in the system. Suppose you have not secured good marks, or you have not cleared your 9th standard, you did not give the result what was expected by your parents. Of course, there is a loss. So then they will think about, why did I give this much time to play? Where I can cut it. Okay, so I try to adjust, I try to reduce or improvise the weight. So what I have mentioned here as 2 hours, 4 hours and 8 hours are the input to the model. Input to the model. With this input, whether I am able to get the output what I expected. Always there will be 2 things. One is the predicted output, that is expected output. Okay, and other one is the produced output. So I am expecting that you secure above 90%. Whereas at the end, when the result is released, I came to know that only 80% you have secured. So the produced output is lesser than the expected output. There is a loss over there. Similarly here, when you consider any neural network or deep learning network, you will set this must be the output of my model. And at the end, after the entire process, when I see that if there is a major deviation, if there is a slight variation, I will just ignore it. When there is a major deviation, of course, I will have to change something in my weight. Some system needs to be changed. But here, with respect to this example, since the expected output, since the expected result marks are not secured, I may reduce the hours of play as 1 hour. Okay, this can be reduced, but suddenly if I reduce, my son or daughter may get upset. So I cannot just reduce from 2 hours to 1 hour. So gradually I may have to reduce. So instead of giving 2 hours, I can give 1 hour 45 minutes and then 1 hour 30 minutes. Like this, even other. So there I reduce, here I increase. Something like that. Some weight adjustment I will have to give, and I have to see the performance. Like I see when she or he in the 10th standard, first internal test or first weekly test, how about his performance. When there is a improvement, I can just proceed with the same weight. But still there is no improvement, I will have to make some more adjustments on the weight. Okay, so the adjustment of the weight, like how much time I am reducing or increasing, is nothing but the learning rate. So based on loss, I made some changes on the way, and at what step, how far, whether it is too aggressive, some parents what they do, cut everything, no playing time at all. That is an aggressive change. Okay, from 2 hours, totally cut. Again, whether performance will be good, there may be a great high or there may be a drastic down also. It depends because their mindset is involved over there. Okay, so I cannot make change on the way drastically. I can do it gradual changes. Right? So that is how we adjust the weight while doing the propagation. Then I check the last percentage is reduced or not, last value is reduced. So I said something, your mark is supposed to be 90. When you achieve this 90 percentage, then I will not do any more changes. Till then I will keep changing it. This week you are given time to play 1 hour 45 minutes. You have secured 90, yes, I stop here itself. Still there must be some improvisation required. I'll reduce some more time. 15 minutes again I'll reduce. And you add 15 minutes into your study hours. Like that I keep changing on the way till I get the expected loss. The loss must be reduced. I cannot say the loss must be 0 because it is artificial. And even human also, every time whatever you expect may not happen. You may think that I have written exam for 100 marks. I will secure 100 out of 100. Okay, but you may not get. Sometimes we may get, but sometimes 1 mark or 2 marks we may lose. Even human brain itself will not be able to predict that. Artificial cannot be possible with the 100%. There will be slight variation in that. When it is able to achieve 100%, that is with a 0 loss, now it becomes a superhuman. It becomes a superhuman computer, which may not be possible always. There will be a slight loss in any of the process, right? So what exactly we do in the, so I will just construct a back propagation network with this itself. Very simple. With the single hidden layer, I will just construct to make you understand. Then we will proceed with the deeper network. Okay, right. So here, what like you will also be able to construct any neural network or deep learning networks. Okay. So here, what are all the input? One is play, other one is study, next one is sleep. So this one we will be interpreting as x1, x2 and x3. Okay. So then you are going to give any hidden layer? Yes. Otherwise directly it can produce or it can join with the output layer also. Okay. Right. So here whatever the weight I make, so I am giving here play time is 2 hours and then study hours 4 hours, sleeping hours 8 hours. This is what is weight. So initially I said something, I give some value. Later on, so for this it will be the computation always, how the computation is taken place in any of single neuron, input into weight plus input into weight plus input into weight, sum of all this, and then here I will be doing something called an activation function. Activation function. I'm out. So activation function, this also we are seeing from the beginning of the subject. Activation function may be of anything. Normally we choose if it is a linear function sigmoid, if it is a non-linear ReLU. These two are the very familiar activation functions applied on any neuron. So once you complete the computation, apply activation on that and then the output will be produced. Output will be produced. This is how we construct anything. So there is no back propagation because everything is a feed forward. Everything is a feed forward. So when I have to do back propagation with this small, simple, single layer, it will not be possible. I will have to introduce some hidden layers over there. With the single hidden layer, I will not be able to get the exact thing. But suppose you want to convert this as a back propagation. So you are getting some output over here. Okay, you are getting some output. So how do you find the loss? Loss will be normally your expected output. So suppose I am naming it as y and the produced output y cap. Okay, so square of this will be the loss. Why we are taking a square of that, sometimes the value may be in minus. Okay, so to get the accurate value, correct value, we are doing this. So loss will be computed in this way. Loss is equal to y minus y cap whole square. So we involve very important functions alone I will teach here. So how do I do back propagation? How do I do back propagation? So here we will be introducing derivatives that you have seen or you have studied already. So we need to perform derivation on the weight. So this is weight. Suppose I am naming it like this: W1, W2, W3. Since after the activation, so this is O1. If I say the weight of this is O1. Okay. So what is the thing I am supposed to do? I have to apply some changes on this weight. I need to make changes on this weight. So here the weight has to be changed, means in third here also it must be changed. So I do from the backward. So forward pass will be, it will go in this manner. What it is producing, that will be happening during forward pass. When I want to reduce the loss, I have to go via backward pass. So I am taking a very simple network only. Then we will take a real network, right? So how do I do that? How do I adjust the weight? So here only another parameter comes, which is eta, is represented by eta. This is nothing but your learning rate. Learning rate. Learning rate is involved over here. So this, using this learning rate only, we will be computing the new weight. W new is equal to, we will be considering this old. See what normally we do. Suppose I have given more time, 2 hours I have given. How do I adjust the time? I will reduce. I will subtract. So I W old minus eta, that is the learning rate. How much I am reducing, what percentage I am reducing, whether I am going to reduce 10% of the actual weight, like I am going to reduce 1 hour or 30 minutes or 15 minutes, what percentage I am going to reduce, that is eta into the weight, W old. This is how I will be adjusting the weight. Okay. So here when we talk about back propagation, these two are very important formula. One is you need to know the loss. Second is how do I adjust the weight. Okay. So now by applying this, suppose I am taking a learning rate. Normally in any of the model, we don't directly start with some 0.1 or 0.8 or something like that. Or we don't take. So we will start with 0.01. 0.01. Okay. So just 10%. Gradually we will be going 1% only it is. So then we will go on and increase the learning rate requires. Okay. So 0.01. So suppose I am taking 0.01 as a learning rate, it will be multiplied with my old weight and that will be subtracted from this. So I will be getting the weight as something like, instead of having 2, I will get it as 1.98. So I apply that weight over here. Similarly, here also I will be doing, here also, because 3 inputs I am giving. So all the 3 values have to be updated. 3 values have to be updated. So here I said just W volt. This W volt is having again a computation where we will be applying a derivation. We will be applying a derivation. Okay. So with detail like derivation on the weight what I am considering, with respect to that weight I will be performing derivation. Okay. So old weight will be considered. So based on that I need to perform derivation. So the derivation value only is taken. I don't take this value directly. Just to make you understand I have given so, but this value is again computed by a derivation function. So for back propagation, derivation is very important. Now how do I optimize this weight or reduce the weight, or how do I reduce the loss? How will I get the accurate result? There are various ways to reduce the loss or to optimize the weight, in which one of the very important learning method is gradient descent. Have you studied this? Gradient descent. Which subject you have studied? AI you have studied. Good. So gradient descent is a method, or gradient learning is a method which we use to optimize the weight, optimize the loss or cost function. It can be called as either a loss function or a cost function. So what this gradient descent does? So normally, to understand again, this will be represented as a, have you seen? Yes, right. So the initial weight somewhere it comes over here, and we need to go to this. Here only we need to reach. That is global minima. Global minima. So when I am having the loss as global minima, my network will function well. There won't be much loss in that. And kept on reducing the loss. So I have to reach over here, but initially I am here. So I adjust the learning rate through which I am able to adjust the weight. Suppose my learning rate is 0.01. So with that, if I process, I may get the value over here. Next time I get the value over here. Slowly I will be reaching here. Okay. So whenever you take this and right side of this, if it is getting reduced, you are going to get a positive value. We need to reach this global minimum point. For that only we will be applying the formula and getting the value through which the loss will be reduced or cost will be minimized. Got it? Suppose initial value is here somewhere. In that case, it is already in the positive age. So that time again it has to be reduced over here. So from the negative end, if it has to reach 0 means you will be improvising the value. From the positive value you want to reach 0 or 1 minimal value means you need to reduce. That is the reason here we are using the square minus or plus. It doesn't matter in this graph. So either it will be going on the reduction end or it will be going on the increasing end, but the formula will be same. Okay. So this is to understand when we will be using. Yeah, one more point, very important point you need to know here. When I am using the learning rate is very, very less. In that case, you will be able to get the gradual change in this. So, once you come to this point, you can stop this process. Suppose I am not having that much patience, so I am going to take suddenly a learning. As I mentioned, some parents may take a drastic decision like I will completely cut your playing hours. Suddenly from here the point will go. I cannot predict at all. It will go here, here, here. The way I adjust. Okay. So that time I will not be able to predict exact the global minima value. When after how many epochs I will be able to reach, because there must be some system or form, right? If I am taking this learning rate, I will be able to reach global minima with this many iterations, with this many epochs. Anything is like that. When you are performing some mathematical computation, suppose if it is too large, infinity time, you are not able to determine how many steps you need to do, you will not be able to have any prediction. You must have some prediction. If I am taking the learning rate as 0.3, I may have to iterate some 4 or 5 times. If I am taking 0.01, I may have to iterate for 15 times. Some predictions will be there because we are feeding everything to the network. Right? The program, you are training your network. So, gradually only the changes have to be taken place. So, with this, I will give you some theoretical points. We will proceed with that. Gradient descent. Take down. Gradient descent is an iterative first order optimization algorithm. Gradient descent is an iterative first order optimization algorithm used to find a local minimum, or maximum of a given function, machine learning or deep learning. To apply gradient descent, you have two very important functional requirements, and they are, because though you understand, you should be in a position to write theoretical part. So few theoretical points for you. So there are two specific requirements to apply your GD, gradient descent. They are, the function should be differentiable. Function should be differentiable. You should be able to differentiate that function. Okay. So I give you one function like y is equal to x square. Will you be able to differentiate this? Yes. So with respect to x, I will be able to differentiate this. Dou y by dou x is equal to 2x. This is possible. This is possible. Suppose I am giving another function like 1 by. Is it possible to be differentiated? முடியுமா முடியாதா? முடியாது. முடியுமா முடியாதா? So this cannot be differentiable. This cannot be differentiable. Okay. So first requirement to apply your GD or to make it as a optimization function, it has to be differentiated. The function should be differentiable. Number 2, it should be a convex. It should be a convex. So for any function, you should be able to draw a convex. Rather than doing so, you are able to write like a sigmoid kind of thing or sinusoid and wave and all. Here, though it is there, it will be difficult to compute. It will. Okay, so it should be a convex. So there are two requirements to apply your GD. Your function must be differentiable and it should be convex. So I think you know what is differentiable. So suppose I am giving a function like this, y is equal to sin x. Is it differentiable? Yes. What is the value for this? It is cos x. Okay. I give you another function. F of x is equal to 1 by x. Is it differentiable? No. F of x is equal to 1 by x is differentiable? No. So first requirement, any function what you consider must be differentiable and it must be convex. How do I say a function is a convex? Okay. So there is again a method to find out whether a function is convex or not. Function has to be convex. I give you an example. B square of fx by dx square must be, see, one more thing. So always we don't take the univariate function. Most of the time we will be taking a multivariate function. That is, with a single derivation we will not be able to doing the adjustment on the weight. We will have to do multiple derivations on the weight many a times. Depending upon the function, we will be performing multiple times derivations on the function. So normally we will be doing at least twice. Okay. So once you perform the derivation, the derivative result must be always greater than 0. Greater than 0, only then your GD will work well. It will be acting as a optimizer. If not, it will not be functioning as a optimizer. So two conditions must be satisfied. Your function must be convex. To know whether it is convex or not, you perform twice the derivation on that function. If the value is greater than 0, you come to know that your function is convex. First one is differentiable. Once if it is differentiable only, you can check whether it is convex or not. Am I right? First condition must be satisfied. Only then I will be able to check with the second condition. If both the conditions are satisfied, yes, it is eligible to be a optimizer. Okay, fine. So few more points for you. Take down gradient, univariate function. Univariate function. Just put one hyphen and write. It is simply the first derivative. It is simply the first derivative at the selected point. First derivative at the selected point. Second, please make it faster. Multivariate function. Put one hyphen and write. It is a vector of derivatives. in each main direction. A gradient for an n-dimensional function, a gradient for an n-dimensional function f of x at a given point P, at a given point P is defined as so how do I apply here gradient function on the y changes? So I take a particular point, okay, with respect to that y, I will be performing derivation. Like that for all the input, I will be applying the derivative or derivations. We'll take a small example for this. We'll take f of x is equal to 0.5 x square plus y square is a function we are taking. Gradient at a point P of 10, 10. Then find out the gradient at point P of 10, 10. So for this, there are two functions given, using which we are going to apply the gradient function on it. It looks like mathematics today. It's not a real class, but this unit is full of mathematical computations only. More than go. If you know, it is a recap. If not, please learn. So here the given is dou f by this is for one point, and for other point we are going to apply both derivation function on the given function. With this point, we are going to compute the residual value, that is how far both are connected, x-axis and y-axis. Whenever it is two values, it is x and y, and this is also x and y. Whenever you even draw line, there must be x and y points, or in a graph, if it is even a point, there must be some x value and y value. Okay, so we are taking just one point and then we are checking, right? Okay, so gradient of, for the first value, apply the formula. Gradient of f of x comma y yeah, how do you differentiate this? How do you differentiate this? With respect to x, with respect to y. Please differentiate it. Marandacha differentiation. If it is x, it will be 2 into 0.5 x plus y square. Okay. So this will be x plus y square Varma. Correct? Okay. Suppose we are doing dou f by dou y. Are you doing properly? 0.5 x square plus y. 2y. Correct? Yes. So now, for the first gradient function, we are not taking any value here. We are going to apply value on it. Okay? So normally we compute it dou f of x comma y and here you got it as 2y. 2y. Apply 10 for x and 10 for y. So finally your gradient function is giving it as f of 10 comma 10 will be 10 and 20. So when you consider this as a slope, on the x side it is only 10, whereas on the y side it is 20. So if it is in the graph, so 10 and here it will go to this much height. Okay, so suppose it is like this 10, 20, 30, 10, 20. So the point will be here. Okay, so this is a simple thing only. Why we have taken for a single point alone, only then we will be able to apply on any of the function. Just to know how the derivation is applied on it. So as a conclusion of this will be slope is twice steeper along y-axis. The slope is twice steeper along the y-axis. Now, gradient descent algorithm. So far what we discussed is just about the gradient function and what is the gradient. Okay, that much. Now we are going to see the algorithm which will be used on our deep learning network. Gradient descent algorithm. Please make a note of it. GDA iteratively calculates. GDA iteratively calculates. GDA iteratively calculates the next point using the gradient at the current position. Next point using gradient at the current position. Scales it within bracket by learning rate. Scales it by learning rate. Ganesh, are you writing or not? Scales it within bracket by learning rate and subtracts obtained value from the current position. So now when you read once you can understand what exactly we are doing it. We are taking the current position. So this gradient descent algorithm will be minimizing the point like to where you want to reach. So you will be minimizing the points step by step and how many steps you want to scale it. It is once or twice or multiple times what it is, that is decided by the learning rate. Why we are minimizing always or why we are subtracting here? Because we want to minimize the loss. To minimize the loss, we are doing the subtraction. No other reason here. So the formula P n plus 1. The notation may be anything, no worries. Ultimately the concept will be same. Theta and the gradient function of Pn. Gradient function of Pn. So what we have done here, the new weight is nothing but the old weight minus theta, that is your learning rate, and then is multiplied with the gradient function. Okay. So please note down what is it. That theta is the learning rate or scales the gradient. Or in other words, I can say it controls the step, like how many jump I have to do. Okay. So that is otherwise called as learning rate. So we say that it has a very, very strong role in minimizing the loss. Your learning rate plays a very important role in the gradient descent algorithm or minimization or optimization of the weight. Okay. Yeah. So one more analysis about this you need to know. When you are taking a very smaller learning rate, gradually only the minimization will be taken place, but you may reach the accuracy. When you are taking a very longer learning rate, that is step is too far. Very long step if you are taking, sometimes you will be able to reach, sometimes you will not be able to reach. Suppose you imagine it is a competition. Okay, so from one place to other place you want to reach. So one person is taking 2 steps. Every time 2 steps, so he is able to reach. He has reduce gradually to, so two steps every time is taking, is able to reach the destination. Other person is taking 4 steps, is reaching fastly, but there is no 4 spaces over there, will not be able to reach. So somewhere it will be stuck up again. You have to change your formula, come back, reduce the number of steps and then proceed. Okay, now we are programming, we are modeling our network. Once you set up the formula cannot be changed. When I say learning rate is 0.01, it itself will not be able to adjust it. Okay, when the process is going on. So always go with the smaller learning rate so that you can, it will take time, the number of iterations may be longer, but the thing is accuracy will be more, the loss will be reduced. When you are taking long steps, unpredictable, uncertainty will occur. Fine, right. So we do follow some steps in gradient descent, steps in GD. So this is a formula I hope you have written. Steps in GD. Gradient descent. First one, choose a starting point. First step is choose starting point. That is nothing but initially I had said 8 hours, 2 hours, study hours, 4 hours and sleeping hours, 8 hours. That is nothing but the starting point, or in other words I can say initialize the utilization. That is the first step. Second step, calculate gradient at that point. Calculate gradient at that point. So whatever the point, whatever the initial value we have taken, with that we need to calculate the gradient point. Third, make a scaled step. Make a scaled step in the opposite direction. Make a scaled step in the opposite direction to the gradient. Make a scaled step in the opposite direction to the gradient. Why we are going in the opposite way? We need to reduce. The objective of this step is to minimize, because you have reached the output and then you understand that loss is too high, so you are going to execute through backward pass. Okay, and at that time you will be taking a step backward. That is the thing. Fourth step, repeat points 2 and 3 until one of the criteria is met. Repeat the steps 2 and 3 until one of the following criteria is met. Number 1, the first criteria, maximum number of iterations reached. Maximum number of iterations reached. Maximum number of iterations reached, because you cannot go on do it. Correct? So you are doing these steps, you are changing, scaling and repeating the process, but how long you will be doing it? There must be some fixed time. You are given time 3 hours to complete your lab. So within that time you can do. Suppose you make a mistake in the first half an hour. Imagine it is your practical examination. You are showing your output. Then you have understood it is wrong. Okay. So you will be given some correction and then you will be asked to repeat the process. Then you are repeating it, but you go on do it, which is not possible. Within the given amount of time you need to complete it. So the repetitions can be limited only 10 epochs or 15 epochs or 20 epochs, like that we will set it and then proceed. Number 2, step size is smaller than the tolerance. Second criteria is step size is smaller than the tolerance. That is the global minima. We say something called the global minima, right? So till you reach, you have to do. After that, you don't have to proceed. So how many times we will be repeating these 2 steps? Number 1, how many iterations you have settled? Only till you reach, you can do. If you are not getting the global minima, or once you reach global minima, you can stop it. Right? So suppose imagine the number of epochs you have decided is 10. With the 3 epochs itself you have reached the global minima, then you can stop it. You don't have to repeat. In other words, you have repeated for 10 times, but you are not reaching the global minima, then also you have to stop it. Okay, so that is the strategy. Example, suppose we are taking one quadratic function f of x is equal to x square minus 4x plus 1. I am taking, what will be the derivation of this? Derivative of this d of f of x by dx 2x minus 4. So suppose we are taking learning rate as 0, we are going to do this problem. Assume the learning rate is 0.1. Learning rate is 0.1. We take the learning rate as 0.1. So we can just set what is my global minima. Once you do one step only, you will be able to understand. Okay, right. So we are going to do for x1. x1 is equal to 2x minus 4. After the derivation, we are going to apply gradient on this. Okay. Okay, fine. So I am going to take the starting point as 9. Starting point, starting value of x is 9. How we are going to do these iterations, that alone we will see. Okay, which means x will be 9 and the learning rate is 0.1. Find out the value for x1 by applying the formula given to you. Initial value of x is 9. Your learning rate is 0.1. So 9 minus 2x. This is my x. Correct. X is replaced by 9. I have taken x is equal to 9. I am doing for the first iteration with the learning rate 0.1. What is the formula you are having? Here weight is represented by x. You are computing for all the gradients. Some 3 or 4 steps we will do. Let us see the value changes and we represent it in the convex. What is the value you are getting here? See, old value minus learning rate into the function. Our function is here 2x minus 4 I have taken. Because that must be derivation of that weight. According to your formula, I have already done the derivation which I have taken. That is the formula, right? How do I apply it here? Old value minus eta into dou f by f of x by dou x. That is the formula, right? So that I have done already, which I am getting it as 2x minus 4. I am applying here. What is the value you are getting? With the learning rate 0.1. 7.6. So 7.6 for the first iteration. This is for the first epoch with the learning rate 0.1. Now this value will be taken. I am having only one input here. That is only x alone. I am not having multiple inputs here. So for the first iteration I have got x1 is equal to 7.6. So when I go to x2, so this will be taken as x and the function is same. Wherever I have x will be replaced by 7.x, like how I replaced x by 9. Initial value of x is 9. So I could take x is equal to 9 over here. Now I have computed the value 7.6 with the learning rate 0.1. For the second epoch, what is the value? Apply this 7.6